Hi, how are you guys doing today? Happy New Year if you're watching this in January, and welcome to my channel. Today we're going to be talking about clean code. The definition of refactoring code is a systematic process of improving code without actually changing the functionality of that code. So when you refactor, you're basically making it way more professional and increasing reusability. So the first time that you solve your problem with code and you get it to work, it can be exciting, but a lot of us have come to face with the fear of changing one thing in our code and not being able to, retain that functionality or having to start all over again. I know the feeling. So clean code is code in its most simplified version. Those who look at it for the first time are able to point out the components, and it's very obvious for them to read it. It's a concept coined by Robert Cecil Martin, and a lot of people refer to him as Uncle Bob. So clean code is really important if you're working with other people, because imagine if everybody was great at the problem-solving aspect of coding, but nobody knew how to communicate their code because it took so much time to read, and everyone has a different coding style, and that's how things go. So there are a few basics to clean code. One of them is no duplicate code. Another one is a minimal number of classes and interfaces and other moving parts, and have it pass all test cases, which we'll get to. I'll actually tell you guys and show you guys how to write a test case in one of my later videos, so stick around. So some more knowledge before I start showing you examples. There's a term called technical debt, and it basically describes how failing to refactor code along the way might as well take the same amount of time, or if not more time, than if you were to use test-driven development the whole time. A little confusing, but I'll break it down. So imagine that you have this thing to code. You can code a big task all in one go, but there's a chance of it, being really messy. You're gonna have to go back anyways and clean it up. So why not just code in increments of your problem? So once you're finished with one component of your solution and it passes all test cases, you don't have to worry about that problem anymore, and you can just move on to the other components. You really don't have to go back and keep tweaking stuff unless you really need to. It's also easier to track progress with that method. The fear of touching something and messing it up, it goes away. So overall, there's less guessing and less stress. To give a little bit more of a descriptive visual, say that you're building a car, right? The car, you need the wheels, you need the engine, and you need the steering, and all the other parts, but building the whole car off the bat is an option. All together to see if it works, and when you do it that way, you could get an error. And sometimes your error is finally coupled within other parts of the problem, and you don't even know where to start cleaning up. And the fear of, messing it all up again is even bigger because you did it all at once. It's just confusing, very confusing. And I think coding is confusing enough, So I think y'all get it. So let's actually show y'all some code. I'm going to be doing an interview prep question that I tried for the first time. Actually, I sat there, let my wheels spin, and deciphered it. I'm gonna show y'all how I coded dirty, and then I'm gonna show you how I clean it up and refactor once I get the answer to my problem. And then I'm gonna show you the test cases and all that. So this is gonna be a little bit of interview prep and refactoring prep. So yeah. I forgot to add a very important point before we move on. We cannot talk about clean code without talking about what dirty code is. So when I say dirty code, I do not mean ever get to California, just give up. No, that is not dirty code. Everyone's code looks like trash the first time they're sifting through it, unless you're one of those magicians. Okay. There's people that are really good at their job and they code really well off the bat, but I'm a messy coder the first time. I break my problem down and I want to figure out the problem first and then clean it up. That's what dirty code is. So dirty code, when we're talking about dirty code, is basically the rough draft, and the clean code is the final, edited down, no comma splices, whatever other parallel I can make to English encoding. But yeah, Key point. All right, little disclaimer. I am the student, not the master. I'm just trying to help people that didn't know this information before. If you want to fact check me, please, please, please do. I don't know everything. I'm not perfect. I'll also have resources linked in the bio, actual clean code book, a Refactoring Guru I found on Reddit, and a link to a coding bootcamp where I met my mentors, Tariq Cook and Stephanie Eldridge. I also learned everything I knew about clean code through this coding bootcamp called Code Differently, and I want you guys to check out their website and what they do for people. And if you're interested in getting into software engineering and you're looking into coding bootcamps, definitely hit up Tariq Cook. That was my mentor. He, introduced me to the whole concept of clean code, and today I'm a better coder for it.
Okay, time for code. Today we're doing this in Java. I decided I wanted to show something on the more simpler side, so we're just going to be squaring a number in this demo. In this video, you see a practice question from my internship that they sent to me. You can find similar IDEs for practice on sites like HackerRank and LeetCode. I'll link down below. So right now, I'm running my test cases to see what I'm starting out with, and yes, they failed. This is good. We always want to start with a failed test case and twiddle our way up. So the input stream gave us 5, and all the code does now is print out the same 5 back. Running it again as if we did anything, and yep, it should still fail. So I'm going to be ignoring everything above the system.out.println because that is necessary so the window can feed us inputs. That is not my problem. So what do I want to name the function that will square this number assigned to the variable line? Let's use a name that's useful, something I can look back and I know exactly what it does. So we're going to name it doodly dupe. Perfect. If I was working on a team, I'd be enemy number 1 right now, but for the sake of this video, I'm going to exaggerate my thought process through coding. One rule of clean code is to make sure that your variables aren't unnecessarily creative and the names of the function should be self-explanatory. So moving on, I'm writing my function outside the main, a personal preference. We know we have to return an integer with this, so that's what we're doing. It's going to be accepting an input integer, so we'll keep it simple and name it input. Very clean. So off the bat, let's just define an integer inside this function because we're going to be using one. We're just going to name it Valerie, just because Valerie is what I want to square. So what's inputted, I'm gonna make Valerie. Perfect. I'm going to be using math.pow. I know that returns a double, so I'm gonna just define my double up here and call it did sum, because we think we doing something. And we're just gonna set it to 0. So with did sum, we're ready to collect whatever math.pow returns. We set that up for the function to take Valerie and raise it to the degree of 2, which is squaring. And finally, if you've never seen this before, this is the syntax. But wait, we're returning a number integer. So I gotta change that double back to an integer. Let's make that variable, and this is called casting. It's taking our double did sum and making it into an integer. Now, if we just spit back and return, I changed it here, logically this should work. Now we run our test cases, which are there to validate our logic. Oop, error. Why? Oh, I see. This is a very simple IDE, and the variable line even though it's a number, it's still a string. So we're going to use a function built into the integer class called parseInt, and it converts the string to an integer for us. Run again and change that comma I didn't see, and boom, we should run again. And it passed. Yes, our savior math.pow has done what it needs to do. 5 squared is 25, and 25 squared is 625. So now that we know our code already works, we can change things around in confidence and further apply the rules of clean code. The only rules of clean code I broke here were complicated names and duplicate code. I'm gonna show y'all what I do. So first things first, we're gonna get rid of that horrid name doodly dupe, like what the hell? And we name it to something that represents what we're doing in this function, which is squaring a number. So square num, and whatever we change here, we have to change there. Next, we're gonna get rid of Valerie. We don't need Valerie. We already have input, so why put it through another loop-de-loop of variable? So it did some, we don't know what we did. So we're gonna change it to dupe, or better yet num, because our intended purpose was to have a variable ready for math.pow to spit something out. But hey, we also don't need that there because it's a duplication, and it's possible to find a double all in one line. So we're cutting down our lines for readability. Beautiful. I forgot I changed Valerie, and we're gonna change did some to num. Perfect. So this is another example. We don't need I changed it here because we can cast one line through our return statement. So example of a duplicate, we can just take that out. So we went from 5 lines of code to 2 lines of code, and our test should still pass. The function still does the same thing, it passes, and we did that in confident. If we were to add something unnecessary and break the code, we could see that our test still fails, and we don't have to go back a lot of steps to get it to work again. Example, I'm just gonna add some rubbish here. Run our test cases, wait for it to fail. Exactly, that's exactly what we did. We're just gonna take that out, simple. So looking at our square num function, I see that we can take it up another step. We don't need that num variable at all. It's yet another one-liner. So from 5 lines to 1 line of code, and it still runs. It's gonna be much less scary to look at. Yep, it should run. Bet. All right, so I'm gonna keep refactoring for the sake of the video. For me personally, I like to have my functions outside of the main, but because this function is only 1 line of code now, I can take what I did in the function and just print that out. So I'm gonna get rid of square num altogether, make sure I cast it, and then use math.pow. Oh, not there. We're gonna put it in the right place. It's not where it goes. Yep, you got it, girl. Math.pow. Leaving parseInt there because math.pow only accepts like number variables. I'm just gonna comment this out because we're not using it anymore. And our test should still, parenthesis. And it should still pass. Yes, we've got it to the simplest version of our code with refactoring. So this is what refactoring is in essence. People do this on a larger scale, obviously, but this is what I did. I think this is fairly accurate. If I never knew how to square a number, this is how my process would go. But the next time I do it, I know I need 1 line. Thanks for watching. Like, share, and subscribe. I'm about to get cut off, but make sure to check back for how to make a test case video and how to refactor a larger scale project. Leave a comment below, and yeah, thanks.